Hi, nice to meet you. I'm Henrique, and today I'm going to talk a little bit about integration tests. So integration tests are often perceived to be bigger, slow, and hard to run. So many developers, because of that, they favor to write smaller tests, basically unity tests with mocks, mimicking low-level implementation details even of, say, database drivers, networking protocols, and such. Uh, this creates some problems. So while it's undeniable that unity tests tend to run much faster, integration tests can also provide better value as they allow you to assess the communication and the behavior of your programs in a context closer to real-world scenarios or basically traffic payloads. So I would say that you should use the unity tests to check the correctness of individual functions and the components of your code, of your application, but you should choose integration tests when you need to test components that communicate with other parts of your system. For example, my experience in this area is mostly with databases, mainly Postgres, and I'm gonna show how you can do it. For instance, I recommend that you using environment variables to obtain execute integration tests with like any resources that might not be promptly available, for example, such as a Postgres instance, MySQL, or any other. And if someone else tries to clone your repository, for instance, and run the tests and it fails right away, this is not that good. Instead of that, you should try to run all other tests that don't depend on that requirement and maybe print a hint that, hey, we also have integration tests. And there are many ways to do so. I prefer to use environment variables, but you can also use build tags or test flags, but I recommend against those because build tags can inadvertently and silently disable static analyzers, so maybe you end up not getting some hints about the bad code quality, for instance, on your test code. And the test flags, they don't function when you run tests using the multi-package mode of the Go test tooling. You don't have to run and destroy, for example, your database. By database, just for client's sake, I mean here Postgres or MySQL or any other service actually. So this is inefficient, you know, and it gets in the way of making tests run as snappy as possible. So it's much more efficient and straightforward to keep the necessary infrastructure running in the background, whether you provision it manually or using any tool. And always ensure that you clean up your environment so that the results or side effects from an old test run won't affect the next test run. The method to do so depends a lot on what you are using and what you are doing. For old school relational databases, that might be as simple as just using drop database, for example, in SQL. And then once you do that, later on when you do the next test run cycle, you can basically recreate the tables, types, indices, or what else you need. And running multiple tests in parallel might require having a separate database or service separation for each test run. Or another similar strategy to mitigate any concurrency issue that might arise. For example, if you are running different functions using t.parallel at the same time, or multiple packages with the same database name and so on. By the way, try to have a single repository package interfacing with a database. I say this because you should keep in mind that there is no concept of sub-packages in Go. And that is actually something that will make it easier for you to write integration tests that work well. And stay clear of excessive reliance on test doubles, test data fixtures, or simple data files if possible, as you might end up in a situation where you'll be maintaining change detection tests with diminished value instead of tests that actually give you good feedback about if things are working as expected. But that all said, have in mind that the integration test is not a solution for everything. So sometimes it's hard to simulate certain types of failures or behaviors with a real implementation. There are some tools like Toxiproxy that can help you with that in some circumstances, but also there are other things that it would be really hard to do so. And unless you are working on a spec defining how a database dev should work, or you want to provide a reference implementation, you don't want it to go this low in the stack. Instead, defining a lean repository interface with methods that you can operate on the database directly, and bridge your application logic in the data retrieval, and then simulating that repository is undoubtedly a better choice. And here we have 6 lines of code where I connect to the database, run the queries, and do basically everything I need. And then after this, the test is done in the call t.cleanup to finish everything. And also, the integration tests, they foster mechanical sympathy, which is quite good for you to have as a developer. And it's a good way to identify problems which tend to have a high impact on your application. So I don't have much time, and here are some resources, and thank you so much.